This presentation will be covering Team Notice's first semester senior design project, a polyphase filter-based multi-channel RF receiver. Our team comprises of our faculty advisor, Dr. Ian DeFranco, our corporate sponsor, Texas Instruments' Thomas Almholt, and our student team members, Nicole Chrysler, Tyler Ely, Roger Chan, Chris Wynn, Bill Hopkins, and Alex Mouth. To go more in depth with the project background, Tyler.
Yes, so modern Internet of Things generally is used for household utilities such as gas meters or water meters. And normally this is done by FPGAs. However, this is very, very expensive. So in order to go be more cost effective, we're proposing a system that uses DSPs instead of FPGAs. To tell you more about the motivation binder solution, I will hand this off to Roger.
Yeah, so we want to produce a DSP implemented solution for two key reasons. One is that IoT devices typically only require a few kilobytes per second of throughput, and for most DSPs, that's pretty overkill and uses more power. And secondly is that FPGAs are really expensive compared to DSPs, so if we can channelize frequencies with a DSP, using efficient algorithms, then we can reduce costs on receiving these IoT device signals. And to explain how we are implementing it, Chris is going to do that.
So polyphase filtering is the key reason why we're able to consider using a DSP, because through taking the transmission band and running it through inverse fast Fourier transforms and using some FIR filters, we're able to channelize a large number of signals into data from IoT devices. And because we're only using this inverse fast Fourier transform, as well as a little bit of reordering, that means that the DSP can handle this very well, especially since it supports math libraries that can do this very easily. To talk about the hardware we'll be using as well.
All right, so the hardware we're going to be using consists of a TI, or multiple TI CC1352s. These will serve as our transmitters, and they'll just transmit a simulated waveform through GSK. There'll be about 50 waveforms. Our receiver will be a TI CC1260, which will receive this simulated IQ data and send it off to the DSP. And our DSP is going to be a TI C6748 series DSP development kit. And I'll go ahead and hand it off to my colleague Alex.
So the way we're going to test this is we're going to have 50 of the red transmitter modules you see over there, and we're going to place them on a board, flash them with the same code, but they'll be transmitting at different frequencies. And then we'll power them all with a USB hub, and then have them send data to the green receiver you see over there, which is going to be connected to a computer. And so the data is going to be showing up on the computer at real time, and we're going to look at the packets and see that their error rate is no more than 1%. And back to Nicole for the
Should you like to test this project out yourself, we will be releasing all associated code and making it open source at the conclusion of our senior design course next spring. Any questions?
Here, 1260 mentioned, TI, CC 1260 mentioned, and you said 1352. So you guys changed it, or?
The 1352 is the transmitter. The
Okay.
1260
is the receiver.
Okay.
So do you scan all the 50 nodes, or are you parallel looking at all those frequencies simultaneously?
We're looking at all the frequencies simultaneously, and so the DSP should be able to channelize all of them.
Okay, so you're fast enough so that the frequencies are all coming at the same time?
Yes.
DSP is able to frequencies separate them all and send them off to okay.
Yeah, and this is done by Polyphase Filtering, which is an efficient algorithm that the DSP can use, so that DSPs can be used rather than FPGAs.
What type of product applications would you use something like this for?
A lot of things for wireless communication. I'm not entirely sure for specific for specific examples, like household utilities for household gas and water meters.
Okay.
These are actually commonly used inside household utilities right now, but they currently use FPGAs. So basically this is the cheaper implementation of that same product.
Like a wireless gas or wireless
Yes, sir,
water heater?
exactly.
Okay.
Is this gonna have a longer range or anything like that? Does it have any advantages other than, is it just cost that you're telling me? That's the difference in having the same amount of capabilities, but it's just a cost differential?
Yes, it's purely cost differential and power consumption.
Power consumption.
So this is
One last one.
one way each device sends to the central controller. There's no transmit back. You don't talk to the devices the other way, right? You just receive only.
The current scope of our project is to just be able to receive.
All right, let's thank the team.